Hi, today let me talk about the let's say more complex types and variables what you can define or use in free Pascal and Lazarus. So earlier I was showing the basic types, which are the integers, real values, different types, text types, character types, and so on. And today we go a bit deeper how you can use more complex types and variables. So basically these types are based on the basic types and extending the possibilities around using a type in different application types. So the first one uh, we can talk about uh, the array types. So there are two types of arrays, the dynamic arrays and the static arrays. The static arrays are arrays where you define from the beginning the size of the array. In Pascal, there is a possibility to define the array with different, let's say, index values. And this you can define from the beginning, and then if you define these let's say sized arrays, then the array size is fixed for the application, and you cannot change the size of the array rate later on. For dynamic arrays, the size of the array can be changed during the application, and basically when you define it at the beginning, the size of the array is 0. Running the application, you define or initialize these arrays, and then you can change the size. You can add or remove elements from the array, and basically you need to uh, work with the size of the array dynamically, so you can address the size of the array within the loops by checking the actual size, the lower and the higher values of the arrays. So let's see how we can define an array. So basically the array definition is looking like a normal variable definition using the array uh, statement, array word. And then if you want to define the size of the array, you can define the values between square brackets, and you can give the values what the array can use. After that, with the off word, you can define what will be contained within this array. So what kind of basic types you will use. It can be basically any of these basic types. As you can see, I was defining here two arrays just to show that you can define the index values as you want. So here the first array is starting from 0 to 10. So basically this contains 11 elements of a real value. The other array is the same size, but it will start from 1 till 11 and also contain real values. In the third array, I was defining a multidimensional array. So here you have two values, which is defining one element of the array itself. And here you can again define the values or the index values between numbers or even letters if you want. But let's stick to numbers currently. So to define a multidimensional array, between the index values you need to use a comma, and then you can again define the variable type, or the basic type which will be held within this array. Dynamic arrays you can define similarly. The only difference, of course, that you don't define the index value. So as you can see here, we have indexed or so static arrays, and in this second declaration group here, I was defining dynamic arrays, one-dimensional dynamic array and a multi-dimensional array. So here, as you can see, you just need to follow or chain up the arrays inside the dynamic array type. So you define array of integer, and then this will be a multi-dimensional array. Of course, you can even create 3 or 4 or 5 dimensional array as you want, but the typical in typical cases you have maximum 3 um, let's say level of or dimensions within an array. So these are the arrays, and the next one is let's say a record type. So here I was just hiding so far the type definition. So when we are talking about complex types, we can basically create our own type definitions, and one possible, let's say, um, type of the definition is the record. So this is what is a kind of typical definition, but of course you can define your own let's say alias to a basic type. And for example, if you define mine integer as integer, then this will also work, and then you can define your variables based on the my integer type. This is basically just aliasing the variables. If you would like to define your own, you can do that. But let's see how the record looks like. So if you want to define a record, then this record can contain many different basic types linked to a variable with a name. So under one variable, let's say, you can create some subcomponents or subvariants or sub variables. And in this case, if you want to link together, or you want to use together some information, like here I was defining simply a user information with a name and the year of birth. And I also defined here another thing, because if you would like to chain up some variables, like you just want to go through certain elements step by step, you can create a link to the next element, and then using this way you can create a procedure or function where you can go through each element just by addressing the next one and going to the next position. So here one additional type or complex type is used, which is the pointer type. And in this case, the forward declaration of a variable can be done with a kind of pointer version or pointer type. So the usage of the record is similar to any other variables. The only difference is that you can um, address each individual elements in the variable by its name, or identifier from the record description. So as you can see, I defined here the T-person type, which is this record type with the name, birth of year, and the next person variable inside. And after the definition, I will show how you can use it. The next, let's say, type is a variant type, and the variant type is a special one because basically this variant type can hold some basic types, not all the basic types, but some specific ones you can link to this variable at runtime. And here I was setting up an integer value and a double value just to show how the variant types are working in an application. The last, let's say, type, what I defined here is a file type. And basically the file type is a type where you can create, let's say, storage elements or storage um, files either on a disk or in a memory um, with the file type. And using the file type itself, you can also define that what you want to store in the file. And in my case, I'm showing it with the T-person record. So this file will contain a T-person object or even more objects, and you can save and load these, or write or read these T-person data into the file um, in sequence, so you can store many of these objects. So these are the complex type, and of course you can create many other types. And what I'm not talking about here are the pointers and some other let's say types which are related to procedures, functions, delegation of functions, and so on. So these are also handled via such kind of type declarations. But later on, when where I will address also these complex behaviors of an application, I will also explain how you can use those. So here in the application, let's say start, or inside the running application, I started with the dynamic arrays. As here for the dynamic arrays, you need to define the length of the array itself, as it is not defined at the beginning at the variable declaration. So for this, you can use the setLength function, where you need to give the array as the first parameter of the function, and the second parameter will be the new size of the array. So here, as you can see, when I'm initializing it, I was initializing it with a size of 12. And why it's important? Because the dynamic arrays are always starting from 0. So I mean the indexing of the array. So once you want to fill the array itself, if you define the size to 12, the highest element will be the element 11. So here, as you can see, I set the element value or index to 11, and I set the value inside this element to 10. In the second case, the set length is actually initializing a multidimensional array. So as I defined it to have a two-dimensional array, I was setting the values or the size to 1 and 1. And here, of course, the size of the the different dimensions can be different as well. So if you have maybe two rows, let's say, and three columns, that's also a possible way of using this. The next lines are just showing how you can refer to the elements, or how you can get the size of the elements, the lower and the higher dimension of the element, and uh, how you can get it for a one-dimensional array, and how you can get it for a multi-dimensional array. So here I was using the low and the high functions to get these lower index and higher index values. And for the multi-dimensional array, I was just taking the high values for the first dimension and for the second dimension. Of course, here for the second dimension, you can get it on a way that you address one of the first dimension, so either the zero or the first or second, depending on the size of the first dimension. The other thing is the length of the array. This can be also, give the overall quantity of elements in the dim, or in the array, and here for the one-dimensional and the two-dimensional array as well. The next element is uh, the record type. So here the person was defined as a T-person record, and once you want to set up the values of this element, you need to use the dot, and then behind the dot the element what you want to address, and then of course you can load the relevant variable type into that element. So here I just use the person name and the birth here, because we don't have other elements defined. And then I was just writing it out uh, on the console. The next one is showing the variant type. So um, if you remember, I defined the I as an integer value and the B as a double value, and the vary is the variant. And as you can see, inside the application, I'm using or addressing or setting up the variant type with the I integer value, and then I'm writing it out. And then the variant is getting another type, which is a double type. And this double type is also written out afterwards. And this will not generate an error, because the variant type can hold different basic types, and even these basic types can be converted from each other. And here I'm showing how this variant is basically um, making this kind of, let's say, conversion. That at first I'm setting the variable again, or the variant again, to an integer value, and then I'm loading this variant into a B, which is a double type. And this conversion here will be, let's say, automatically done. So when I'm writing out the B value made from the variant, I will get a double value, just the same as the integer was, but I will have also the decimal digits behind. The next one was the file type. So the P file was defining this file of person. So inside the file itself, where I'm assigning the file variable uh, to a person dot file, and starting the or setting it up for writing. Then I'm writing into this file the person information. So basically this one what I used here will be written into a file, and then I'm closing the file. Then to just show the read function works properly, I'm deleting the information from the person data, and then I'm resetting the file for read, and then I read out one element because I didn't write any other, and then I close the file. So basically the previously written information into the file will be read back into the person variable, and then I'm writing it out to the console. So basically with this the all the types what we defined is addressed with some functions. And now if I'm running the application output will be let's say written into this console, and you will see how the variables are behaving. So if we are going through again the application, as you can see, I set the length here for the one-dimensional array, and then I was setting the value to 10 at the 11. And when I was reading out the lower and higher um, index values from this array, then I get a 0 and an 11. Similar for the multidimensional array, where I define the lengths to 1 and 1. This means that the highest value is 0 for the index for both the direction or for both dimensions, and the lengths of the different arrays. So the one-dimensional array is 12, of course, what we gave here, and also for the multi-dimensional array it is 1 and 1. Of course the values from the person name and person birth year is of course written out just as it is defined. And the most interesting thing is the variant here, where you can see that when the variant is defined or let's say initialized with an integer value, then the value is written as it is. The b value we define to be 3.14, so it's initialized with the p value for 2 digits, and then it is written out just as it is. Of course, here, if I would not define for the, let's say, for the converted value, so where we were, let's say, initializing the variant with the 2, and then we loaded the variant into the b value became a double, and this double is of course used as it is, so the maximum amount of decimals can be used, and the format of this b value, if it is not formatted like here, then it would be of course a kind of let's say scientific format. And then the file itself. So as you can see here, I was not writing out just after I read it back from the file, and then I got back exactly what was inside the variable earlier. So just to show this as well, so here is the file, but now I'm deleting it just to show that once you run the application, and let's run it until this point again. So now we are running it, and then the file should be already there. Of course I should read this. It's here, sorry, it's already here. So if I'm opening it, then you can see that the name of course is visible, but the integer value behind is of course just used as a byte format or word format, and it's not really a readable form. And when we are running it further, of course, so here you can see that everything is written until this point, and then if I'm running it through, then the values read back from the file and written on the console. And just to show how the variable should look like if I'm not using the formatting, then you can see that the B variant or the variant loaded into a double version, then it would show it in this scientific format. Okay, so that's all about the complex types available in Lazarus, and of course you can um, let's say use them as described, and you can even define more complex types as well. Uh, but these are, let's say, the first step uh, to use not just basic types, but also this kind of special, let's say, more complex types in your applications. So that's all for today. I hope you enjoyed this tutorial, and if you enjoyed it, then please don't forget to subscribe. And with this, I wish you happy coding, and see you next time.